coming up next on This Week in Radio Tech. Seriously, my boss is my guest today, so I got to be best behavior. Everything's got to go well. But we're talking about something cool, and that is containerized software. Docker containerized software. What is it? When will you be using it? And what do you need to know about it? That's coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics with the Bionics Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts. Hey, before we jump into the show, breaking news. Just got this in from Nautel. Here's what's going on. They got a couple promotions, and Transmission Talk Tuesdays are back. So promotion number one, you get a free second backup exciter promotion. Now, you get a free second integrated redundant exciter on any GV series transmitter. Contact your Nautel rep or go to the website nautel.com/11things. That's 11 things. nautel.com/11 things. The other promotion is the 4610 VS Savings promotion. What does that mean? Well, it's three offers in one. You get $4,000 off the purchase of a VS 2.5 transmitter. Hey, I've got one of those. Love it. You get $6,000 off the purchase of a VS HD digital exciter. I'm thinking about that. I think we're going to do that. And you get $10,000 off if you purchase both. So you can add those two promotions together. $4,000 off of VS 2.5, $6,000 off the VS HD digital exciter, and $10,000 all together. Contact your Nautel rep or go to nautel.com/4-6-10. Okay, it may be hard to remember. I'll put those in the show notes so you can click on those easily. Finally, Transmission Talk Tuesdays starts June the 8th. June 8th. And every Tuesday, June 8th, 15th, 22nd, and 29th. So what you need to do is go to nautel.com/webinars. nautel.com/webinars. Register yourself there. It's easy to do. And once you fill it out the first time, it'll probably autofill itself. And you get an email back with the link, and it'll auto-populate in your calendar. It's just great. So check it out, nautel.com/webinars. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb there at the top of the tower. It really did come off a tower, from Lula, Georgia. Thank you, Charles Kinney. It's the show where we talk about radio technology, everything from audio to RF to digital stuff. And today's topic is going to blow your mind. If you haven't heard of this, you're going to go, wow, or I didn't know we needed that. If you've heard of this, you're going to say, yeah, I've heard of that, and now I know more about it. And if you know all about it, great. Maybe you can put some notes in the YouTube comments and tell us if we're wrong about something, but I don't think so. I'm Kirk Harnack, your host here on This Week in Radio Tech, and my guest this week is a friend of mine. I've known this guy for years. In fact, I think I invited him to speak at the SBE meeting in Nashville about 200 years ago. It's Cam Eicher. Hey, Cam, welcome in.
Thanks, Kirk. That was back in my different life, because not like you, I'm not 200 years old. But that's okay. We could really date ourselves and talk about the days when I used to sell you equipment back at Allied Broadcast.
Oh, that's right. Of course. Oh, my goodness. See, back then you took orders from me, and now I take orders from you.
Oh, it's a terrible thing. Who would have thought?
Cam is actually my boss. I report to Cam at the Telos Alliance, and a great guy to work for. I really appreciate his tutelage and carrying me along, and encourage me to do projects that hopefully are worthwhile. And this thing that we're going to talk about today has just been amazing. Cam, tell you what, we're going to get to that in a second. I want to make a quick shout out to my friend Ray Top at Radio Guide magazine. There we go, full screen. Radio Guide. You get to Radio Guide on the web by going to radio-guide.com, radio-guide.com. And what I like about Radio Guide, first of all, it's a big format. It's easy to read, big pictures. You know me, I like big pictures. And they have room in Radio Guide to give you in-depth articles about engineering, about broadcast engineering. Here's an article by Steve Callahan about a flameout on a tower, and he tells you all about the troubleshooting, what happened, how they fixed it, how they found what the real problems were. And every couple of months, Radio Guide comes out. It's 6 of them a year, one every couple of months. This happens to be the March-April 2021 edition. So if you would, check it out. radio-guide.com, and I think you're going to like it. Raytop, we like your magazine. Thank you for being such a good publisher. All right, back to our program. This Week in Radio Tech, number 547. Cam, I first heard this word, I don't know, maybe a year ago. I was listening to some other podcasts about IT technology, information technology, and internet technology and computers and stuff. And they mentioned this thing called a Docker. And then they mentioned this big old fancy word, Kubernetes. And I thought, oh my goodness, what is all this stuff? I'm just a lowly broadcast engineer. We're going to be talking about Docker on this show. Give us a little preview. What's bringing this topic to the fore?
Well, the topic today is all about virtualization. As most of your viewers and listeners here know, a lot of things are moving into the virtual world, and the idea of getting your radio broadcast equipment that you need off of dedicated appliances and figuring out how to run it in a computer or in a virtual machine. It's no secret when you pull the cover off of a lot of radio gear these days, there's just a PC inside, whether it's an ARM processor or an x86 processor. These things can be more or less made out of standard off-the-shelf components with a fancy front panel or some sort of fancy back panel that turned it into a piece of proprietary radio gear. So what better advantage, what better way could you move the industry forward than to disconnect the technology from that hardware package and just run it in a set of virtual machines you might already have, or build out your own set of virtual machines for things like your automation system, maybe your telephone system, and maybe even your audio mixer. So as you move into the world of virtualization, all the cool kids are using this thing called containers. And so we decided to look into it here at Telos. And sure enough, the guys at Google, the guys at Amazon, they have something cooking when they start using containerized software. And the more we looked into it, the more we realized this is really the direction that we need to be going with our virtualized equipment. And here we are.
So you've mentioned a few phrases here that some of us are already familiar with, and one of those was virtualization. And we know that can mean a lot of different things. I've got an iPhone here, and that's kind of virtualization because it can be a walkie-talkie, it can be a telephone, it can be a camera, it can be a calculator, all these things are virtualized on here. And so virtualization is a big word, but in the context of our conversation, we're talking about, I guess, putting computer functions that normally happen on a computer platform like a PC, but we're putting them in software on another platform that may at its bottom be a PC or a server, something that's got some power to it. Yeah.
Pretty much exactly that. When you open up the box of let's say Omni 11, inside that Omni 11 is an industrial computer x86 motherboard. Probably i5 or something like that is running in there these days in the latest generation. Earlier ones might have even been something like a Core Duo processor. So these Intel processors and these industrial motherboards are the heart of many broadcasters' products, not just Telos, but Nautel transmitters use motherboards inside them and processors. Even the car in your driveway has got some sort of motherboard or processor in it anymore. People make that complaint that they can't work on their car anymore because now it's just a computer. Yeah. So we're really doing the same thing here in virtualization, is rather than having these units locked inside boxes, with a beautiful Omnia logo on the front, we're trying to take the technology that we provide, whether it's great audio processing or audio mixing, and allowing people to deploy that in different ways for their facilities. Now, before some of you go, hey, listen, I still want a box, Telos is not getting away from making hardware appliances. We just know that in some instances, people need the flexibility and the additional power that running things on a PC or a virtualized platform can provide. And so here it's all about options and giving broadcasters another way of deploying that technology in a way that might better suit them. And to kind of whet your appetite a little bit, one of those solutions might be, what if you could run 10, 20, 30 Omnia processors inside of a single rack of PC gear? And so could be interesting.
Yeah. And now a lot of us are somewhat familiar with virtual machines. So, I'm no IT whiz, but 5 or 6 years ago at one of my radio station clusters, we decided to put a bunch of Linux machines onto a server. And of course, there was a hypervisor level. It happened to be a distribution of Linux that can act as a hypervisor. I believe it's called KVM. And on top of that, we installed several Linux machines and a couple of Windows machines too. And each of the Linux machines was running a Rivendell instance. It was using the Axia IP audio driver for Linux, and that amazingly worked. And then the Windows machines, one was doing streaming, one was, I forget what else it was doing, but maybe some ingest from FTP ingest. And these were all running on one physical high quality. It was a secondhand server, but it's very high quality, dual power supplies, all rated hard drives, 2 processors, lots of RAM. So we were getting, yes, a kind of expensive hardware platform, but we were getting great use of it. And those were individual virtual machines. And I get that concept, and I think most of us do. But when one of them, when one of the Linux instances wanted to do a patch, an upgrade, something like that, well, they all did. So it seemed like there was a lot of weight going on here. 5 instances of Linux, all of them the same, all running. And so we're used to this idea, and it seemed really efficient, 10 years ago, maybe 6 years ago. But now there's something that not exactly new. It's been around 8, 9, 10 years, and that's this thing called containerized software. Now, we're going to take a break in a minute, but why don't you just kind of open the door? Because that's what this show is not about virtualization in the traditional VM sense. This show, we're going to talk about this idea of containerization and how that's different and more efficient. Why don't you kind of wet our whistle on that topic?
Well, that's exactly what we're here to talk about, is another way of deploying virtualized systems. And whether it's a different name for a virtual machine or a different type of deployment, as you mentioned, Kirk, we're talking about container deployed software, and container is just a different kind of virtual machine. The real challenge for really any broadcaster, but Telos in particular, is how do you improve the performance of a typical virtual machine such that it can process 10, 20, hundreds of real-time audio streams at the same time with no real latency, no audio dropouts, no glitches. And quite honestly, virtual machines in their current state don't do a good job of that. So we were looking for another way of how can we optimize that performance to really be able to get the telephone systems or audio processing systems, or even, as we said before, audio mixers into the virtual environment and get the kind of performance that the industry needs. And that was the missing link for us and the challenge we had to overcome, and welcome containers.
Well, I think we can see that if you're running a bunch of actual virtual machines, a bunch of Windows instances or Linux, you've got overhead there that the processor, the CPUs are having to service. And if we could somehow make that more efficient by not having all these operating systems, but somehow have a more efficient way, like we're going to talk about, containerized software and a container engine, in this case, a Docker engine that handles requests between the applications that are running, the containerized software, and the OSs, we actually get a more efficient way to do. We can do CPU affinity. We can tell a CPU, hey, you handle this container, you handle this container. So we're going to get into all that. You've got a presentation for us. And by the way, friends of the show, TWiRT, what really inspired me to ask Cam to come on the show was not just to score brownie points with my boss, but Cam gave this presentation to us at Telos Alliance, and I thought, this is so teachable. This is instructive. This is a technology that we as broadcast engineers really need to know about. And so, Cam, thank you for coming on the show, and I'm looking forward to the prezzo. We'll have it in just a minute. Meanwhile, this week in Radio Tech, our 547th episode is brought to you in part by our friends at Broadcast Tools, and of course distributed by our friends at Broadcasters General Store. Broadcast Tools makes all kinds of things that will really help you out as a broadcast engineer. Gadgets, gizmos, interfaces between different things, silent sensors, all kinds of remote sensing stuff. But one thing they make is the ProMix 4. It's a 4-channel mixer with USB. And I know there's other 4-channel mixers out there on the market. They're all, the consumerish kind. You put them in a Pelican case once or twice, it comes back with knobs popped off, and it's not good. And there's no tally light control, for example. And there aren't the kinds of headphone monitoring provisions that you need. Believe me, I own a couple of El Cheapo little mixers with USB on them, and I've done TWiRT show with them, and they neither one of them provide the exact monitoring that I would really like to have. Well, the ProMix 4 is a full-featured audio mixing console, and it's perfect for most broadcast studios, but really excelling in remote broadcast and podcasting. It has 3 microphone and or line inputs, as well as a dedicated line input that you can switch between the balanced line input and the internal USB codec. Of course, that'll be tied to your laptop. Other features include a program limiter, a balanced and an unbalanced mix bus, and a mix minus output. It offers 3 independent headphone amps with IFB, program, and pan controls, along with a comprehensive studio monitoring system. It also has 3 universal mic binaural line level input channels, 1 mono balanced line level input. By the way, you notice I'm saying mono here. This is a mono console. It's so easy for a DJ going out on a remote to set up. Doesn't have to worry about getting left and right balanced right. There's no left and right. It's a mono console. It's perfect for the applications like going out in the field or doing podcasts. It also has a built-in USB codec to hook to your computer for audio playback and for recording. It even has a mix minus output. Yeah, it does that, and you don't have to think about it. Plus an LED audio output level meter and full duplex talkback capability when you use the ProMix Hub 6 controller. That's sold separately. 3/4-inch stereo headphone outputs, independent volume, IFB pan, and program pan, and an on-air tally warning light relay output. Plus, it can drive multiple of the AHR1 Plus headphone system. This is the ProMix 4 from Broadcast Tools. As they say at Broadcast Tools, problem solved. You want to pick up your ProMix 4 from Broadcasters General Store. You can get to their website at bgs.cc. That's bgs.cc. Or you can give them a call at 352-622-7700. Yeah, I've got that memorized. Been calling that number since about 1989. That's Broadcasters General Store at 352-622-7700. Good folks there at Broadcasters General Store. Thanks a lot to Broadcast Tools and to Broadcast General Store for sponsoring This Week in Radio Tech. All right, it's episode 547. Cam Eicher is my guest. He's also my boss, so I'm being extra polite. Thanks, Cam.
You're making me uncomfortable, Kirk.
All right, Cam, I'm going to let you take over and just jump into this. I'm going to interrupt you when I have a question or silly comment. And by the way, what Cam is talking about here in this Docker container explanation, I'm doing right here at my office. I'll tell you what I got during the show. But Cam, you take it away, sir. Go right ahead.
Well, thanks. And like Kirk, I was new to a lot of this. So as Telos jumped into the world of this virtualized, containerized Docker, Kubernetes software world, there's a lot of learning to do. And what I quickly realized is in my role at Telos is managing the Telos Alliance sales team, and realizing that we're going to have to talk to you guys, our radio broadcast customers about this stuff. We better get ourselves up the curve pretty darn quickly as to how this technology works and what benefits does it provide, and is it something that our customers should really believe in? And so realizing that whenever you're dealing with a whole new world of technology and a whole new world of vocabulary and definitions and things that you might think you know. So all of a sudden the word virtual machine starts getting batted around and you're like, well, I know what that means, but do I know what it means in this particular application or this particular instance? So after talking with some customers, talking with some of our great dealers, Broadcasters General Store is one of them. We had some meetings with their sales staff, and we started to realize that, once again, Telos is a little bit ahead of the curve here. And just as we did introducing some of our fabulous products, audio over IP, we came out with that and then realized that, boy, we're going to have to do some teaching in terms of the broadcast industry and helping them understand what audio IP can do for them in their facilities. We want to be able to take that same stance with containerized software and the direction we're going and make sure that everybody really understands the benefits of this. So we kind of went back to the beginning. What do broadcasters need to know? How can we package that in kind of an easy to understand manner and kind of walk you through the building blocks of, let's say you wanted to build a computer that wanted to run some containerized software, what might that look like? So what we're going to run through here is, again, it's a pretty introductory level. I don't claim to be an IT or DevOps or a network administrator type of engineer person. Like most of us, I know enough to be dangerous. I know enough to get myself in trouble. And I know enough of when to go hit the internet and look for help. So that's what I did with this presentation, is dug into some of the 3 steps that are going to be needed to deploying some containerized software. So we kind of said, look, let's start with the platform. We have to define platform. And what a platform is, in this case, is the type of hardware or the type of PC or the type of server that you're going to deploy this software on. It has to run on something, so let's figure out what are the choices in terms of the platform that you want to deploy. Now, I'm surprised that we're into this presentation for this conversation with Kirk for maybe 20 minutes, and none of us have said cloud yet. So we're going to see that jump into the conversation here in a minute, because along with virtualization, everybody gets really excited about cloud deployments. So the first way that we can deploy software and the platform that we can use is on something called a bare metal server. And I have a feeling that bare metal server is just one of those terms that somebody in the IT world came up with just to make us non-IT people feel like we're on the outside and we don't quite know what's going on, because they could have just said new PC. They could have called it a lot of things, but instead we came up with the term bare metal. And a bare metal server is really just a real physical server. It's meant to distinguish itself from a virtual server, which is, again, maybe a virtual machine, or a cloud server, which is a server that somebody else owns and you're leasing it or leasing space on that server. But a bare metal server is something in your hands that you can touch, that you can work on, and that you can install software on, and you can put a USB key into it, and things of that nature. So a lot of what we're going to talk about today, and a lot of, if you wanted to do this experiment at home, is with a bare metal server. That's the easiest point of entry. Doesn't really require any special expertise or anything to get started with it. You just need a piece of hardware. Now, in full disclosure, at the bottom of each one of these slides that are up here, you're going to see the always accurate Wikipedia link. One of the ideas behind this presentation is just to give a quick snapshot of what these terminology, the vocabulary that we're using, just to give you that introduction, and anything that you might want to dig into. The Wikipedia articles are actually pretty accurate, and they do a really good job of going into more depth if you really want to get into the nuts and bolts of how some of these things work.
You know, Cam, what I'll do is on every show, we have show notes, and those appear on my website, thisweekinradiotech.com, also on the GFQ Network website, and I believe also in the YouTube show notes in the description. So we'll have these links in the description. Obviously, you can't click on your video screen here and get that, but if you want to get them in the show notes, look there, and we'll have these.
Perfect. And if any of you look at this and decide that, this would be good for your radio station group, if it would be useful maybe for an SBE chapter or something like that, we're happy to share this information. Again, the idea of educating our customers, educating our friends, that's really what we're all about here. So any way we can help you, if you think this is useful information at the end of this, let us know how we can help disseminate it even further.
Okay.
So bare metal is one option of how you might deploy containerized software, and the second is the cloud. Now, I love the graphic here because it exactly describes what the cloud is. There's not really a cloud up there. It's just Amazon's computer, and Amazon will be happy to lease you space on their computer, as will Google, as will Microsoft, as will a half dozen other people providing cloud computing resources. So cloud computing is a bank of computers that somebody owns, and you are allowed to install software and run your programs and store your data on their server. You don't have to worry about power. You don't have to worry about managing the hardware. You just have a pipe that connects you in, and you can run your containerized software. You can run virtual machines on any of these popular providers. Now, there is another third option, which is called a public cloud, a private cloud versus a public cloud. So An Amazon server would be a public cloud, a Google server is a public cloud, but you could also have a bank of servers at, say, your corporate location. And you could install all your automation systems at your network center facility, and then your regional stations would tap into those resources at your corporate location, wherever that data center happens to be. And it's not available to the public. You're not necessarily charging each one of those remote locations. You're managing all of that infrastructure as part of your company, and that just becomes a private cloud. Now, you do have the option of going to Amazon or Google and actually leasing hardware as opposed to leasing space on the hardware. And so you can create these virtual private clouds and things of that nature that will provide you the same capability. You're now paying a third party for a private cloud as opposed to potentially sharing that server with somebody who's selling blue jeans or something else on that same shared server. So lots of different methods, and it's really about cost. How much do you want to spend on the hardware itself? Do you have the right staff to manage that infrastructure? Is it more convenient to pay by the minute or pay by the hour for cloud storage? Or is it easier just to get a server and stick it in the back in your room and do it all yourself? So a couple of different options for the platform that you can use to deploy this various containerized software. And by the way, this works just for regular virtual machines as opposed to containerized software. And it works just for things like data storage and backup. So think about how your station is doing backups for the accounting department and the sales department. Do you just have a network drive off in an office somewhere? Or are you paying a third party to do data backups for you? And that's kind of the same idea of how clouds work for virtual machines as well as for things like data storage.
Okay. Mm-hmm.
So we've kind of defined a machine with our three different options of the host machine. So we either have this real bare metal machine, or we're doing something on somebody else's machine, which we're going to call the cloud. So Step one, we can check the box. Then we get into the part that's a little new for containerized software is operating systems. Now, operating systems, when you say that, most people go instantly to something like, well, operating systems, right? It's Windows, it's Linux, or it's Mac.
Mm-hmm. Yeah.
Almost. So as we get into containerized software, operating systems become a little bit different. So we're going to start with talking about virtual machines and how virtual machines work. And so just to remind everybody about virtual machines, remember, a virtual machine is more or less a pretend computer. It is a software. It's a software representation of an actual computer. So inside of the computer that Kirk was talking about in his rack room, he has 5 pretend computers, each one of those running a Rivendell system or a traffic and billing system or a Mac operating system, or each one is its own independent computer doing some sort of functionality. So they work very, very well. They are very easy to deploy, and it allows a single server to perform the functions of potentially dozens of computers. You're really only limited by the raw processing power and the raw memory that you have available inside your bare metal machine. So if you go out and score yourself a really nice 32-core fast machine with 128 gigabytes of RAM, you're going to be able to run dozens of virtual machines in that without breaking a sweat. You can also scale something quite a bit smaller, have an 8-core machine, 16 gigabytes of RAM, and still run a half a dozen virtual machines with no problem at all.
Okay.
Now there's a new term here. Kirk used it earlier, but a term called a hypervisor. And I say new only because we've only started using it recently. So I've been dealing with virtual machines for, 10 years or so, partly because I'm a Macintosh person at home, and there's a lot of Windows software in the world that I have to run. So I've been running virtual machines, running Windows on my Mac for a long, long time. And the term hypervisor never really came into play until recently. But what a hypervisor is that's the virtual machine software or the virtual machine call it a monitor. So that's the software that creates and runs your virtual machines. So on my Mac, I have two different hypervisors. I have VirtualBox that creates and runs virtual machines. That's a product from Oracle, a really nice free virtual machine product. And I have Parallels, which is another paid-for subscription that allows you to run Windows and Linux and other distributions, again, on a Mac.
Okay.
There are cheaper ones, there's free ones, there's more expensive ones, and there's ones that run directly on Windows. You can run VMware, you can run VirtualBox on Windows as well. And again, on your Windows machine, when you create that virtual machine, you'll say, I want this virtual machine to be another Windows machine. Maybe you want to set up a Windows XP machine or a Windows 7 machine to test some software in, or a Windows 10 machine to do something specific. You can choose the operating system you want. You can choose the size of hard drive you want. You can choose the way the network interfaces work. And essentially, you're building a little pretend computer inside your physical hardware.
Just to be clear, on your Mac, you're running Parallels, and I've got Parallels on my Mac as well, but you're also running VirtualBox. In both cases, aren't these, I guess what you might call a Type 2 hypervisor? In other words, they are each depending upon the Mac OS for them to run, and then you can run more VMs inside of them. So you're kind of one level removed from what you're going to talk about, I guess, and that is a Type 1 hypervisor.
Exactly. So
Okay.
This is a great distinction. So a hypervisor is a hypervisor world around. I think it's just a fancy name for virtual machine software. Again, trying to put some sort of terminology on this that can be relatable and translate across all these different brand names that we're talking about. But the hypervisor software would be, in this case, Parallels or VirtualBox. And it runs on top of the Mac software, on top of the Windows software. So it's still doing its own thing and having an interface with the operating system that's on your hardware. Type 1 or Type 2. So what is that and why is it important? And what we're talking about is a Type 1 hypervisor is actually in some ways an operating system. And that's why this is in the operating system section of this little chat we're having. Mm-hmm. So a Type 1 hypervisor runs directly on your hardware. So if you had that bare metal machine with an empty hard drive, you're not installing Windows, you're not installing Linux, you're not installing DOS. On that bare metal, you're installing either Hyper-V or a special version of VMware, this VMware ESXi. Mm-hmm. And that operating system and that hypervisor goes right on the bare metal without any other Windows or Mac or Linux OS in the middle. So it's really not in the way. And that allows a lot better performance and a lot better tuning that you can do between the hypervisor environment and the computer CPU itself. You don't have the operating system getting in the way. We all know that Windows and Mac have a lot of things running in the background and a lot of things that they're trying to do. And maybe right when you're about to run that audio spot, they decide to re-index the hard drive. And all of a sudden, all of your CPU goes to indexing the hard drive, and you're wondering what happened to your radio program. And we don't want that. So keeping the operating system out of the way is a really good thing. Now, the Type 2 is what most people have used as hypervisors, and it's what most people are comfortable with, is you buy Windows and then you have this program you download that lets you run virtual machines on it. And those work just fine for lots of things that are not real-time audio. In fact, there's a version of VMware that is a Type 2 hypervisor that does a great job running all sorts of third-party software, but it runs on top of a Windows operating system. So the way we look at that is with a cute little graphic here, and you can see that there's an extra layer of stuff in the middle. So we've got the hardware down at the bottom of this diagram, and look at the little clouds across the top and pretend that those are the applications or the containers that you want to be running with your containerized software. And in the left-hand example, the Type 1, it's just the hypervisor managing those containers. In the Type 2, You've got the hardware running an operating system, the hypervisor sitting on top of your operating system, and then the hypervisor is trying to run its own operating system across multiple containers. And that gets to be problematic when it comes to this idea of real-time, low latency, high bandwidth audio.
Okay. So, I think about this as a type 2 hypervisor is what a lot of folks are familiar with Parallels on a Mac or VirtualBox, as you said, on a Mac or PC or Linux. And that's, to me, that's not for doing, not that it's not for serious work, but it's certainly not for real-time work, because there's a lot of layers between the thing that's working hard and the CPU. But a Type 1 hypervisor is an operating system that was designed and built to host other operating systems, to provide a virtual environment, a pretend computer for numerous instances of that, and tying it to the managing its relationship for each VM to the hardware so it has the resources that it needs when it needs it to get its job done, perhaps in real time.
Exactly. And some of this is, it works until it doesn't work. So a lot of us folks that have been messing around with Livewire audio have tried to spin up the IP driver for Livewire inside of a Type 2 hypervisor. And it can absolutely work. As long as you don't try to do too much, or again, as long as you're not trying to run Google Chrome in another tab, and then all of a sudden that takes all your CPU cycles away and your audio starts buffering and jittering, and you've got all sorts of challenges and problems. As they say, it works until it doesn't in a Type 2 system. Okay. And again, it's not that it can't be for serious work. It's really about knowing what is going on with your system. So we talk a lot about separating AOIP networks from your business network. And the idea is that you want to be able to manage that traffic. It's not a hard and fast requirement, but if you're unable to manage that business network, then it should be a requirement, because you don't want somebody streaming a whole bunch of Netflix in the back and then wondering why the audio for your broadcast is not working right. So as long as you've got everything partitioned correctly, it can work just fine.
It might be worth pointing out that in the Type 2 hypervisor, like Parallels or something like that, the OS that's underneath it, Mac or Windows, it's treating that hypervisor like another program. It's not necessarily going to give it lots of time and resources and attention if it's got other stuff to do, like you mentioned, a busy Chrome tab. Whereas the Type 1 hypervisor, that hypervisor was designed to give each OS that it's hosting the resources that it needs, wants, or is configured for, so as to do as many things as possible and not shut anybody out when they need resources.
Exactly. And that's a thing that we call CPU pinning, the idea of physically allocating CPU cores to a particular virtual machine that the hypervisor has created. Okay. So that allows us to allocate and really segregate specific CPU resources for each intensive task. And again, that way you're not running out of CPU cycles right when the news hits at the top of the hour, because sometimes that's, exactly when Chrome decides to do their update. Or again, we've all been down there where you turn on your computer and you're ready for your webinar and it says, please wait, downloading a Windows update. Yeah. So you don't want any of that messing with your on-air sound.
All right, good.
So the third component of operating systems, so we've talked about the various ways of deploying virtual machines. Once we get our virtual machine installed, now we have to have an operating system in that virtual machine to do the things that we want to do. And the operating system that Telos has chosen is a version of Linux called Ubuntu. Now, there's lots of versions of Linux. Some are actually commercial versions that you can pay for. And what you're really paying for there is the support of experts in Linux. So if you get stuck, there is somebody that'll reach out and help you, and you're paying for support time. But sort of by definition, all of the Linux distributions are open source, and Ubuntu is one of them. It is a free distribution, doesn't cost any money, there's no license fees, and there's several varieties available if you want to use a desktop version that has a nice graphic user interface, or a server version that has a little bit more power but requires you to know a little bit about command line interfaces and how to navigate without the nice use of a mouse and a nice GUI.
By the way, I think this slide is where we would probably cause angst among some Linux devotees, right? Because everybody has their favorite distribution of Linux, and Telos it's not that we chose Ubuntu Linux because it's better than the others or anything like that. We had to choose a Linux so that we, Telos, would become experts on how things worked in Linux, because each distro is a little bit different to the angst of some other people. Where files go, what the names of different folders are, it's not all the same. And so we had to choose something to be expert in. And Ubuntu is widely distributed. You may have more to say about this, but I'll just finish up by saying we had to choose something so that we could actually help people with a standard installation of what you're about to describe. And so Ubuntu, some of the couple more recent versions, had the things that we wanted. We knew where things were, and so we can provide expert help with Docker containers, which we're getting to, in this version of Linux. Doesn't mean it doesn't work in other Linux versions. It just means that we can help you with this one.
Exactly. And that's the comment up in the right corner there in orange. It's our preferred distribution. It doesn't mean that it won't work in any of the other varieties that are listed. All it means is that our guys are not experts, and we're going to have very limited ability to help you. And one of the things that we're developing are some really nice tools to ease the installation process and to make these systems a little bit easier to deploy. And if we're going to do that, we have to kind of drill into a standard. We can't provide special scripts and special installers for all the different varieties out there. So it's really just about being able to manage the amount of support that we can give our folks.
Gotcha. Okay.
So we now have our hardware picked out, whether it is our hardware as bare metal or hardware in the cloud. We have got on the left-hand side decided that we're not going to go with a hypervisor. We're just going to install Linux directly on that host and be ready to install our Docker environment and our Docker containers on top of that. Or we, on the right-hand side, we can get a Type 1 hypervisor. In this case, we've chosen this VMware ESXi. We can deploy virtual machines on top of that, and one of those virtual machines we're going to use for our containerized software.
Oh, so either one of these situations will work fine then with containerized software? Yeah,
it will. So the situation on the left is simpler. It's actually, if you have the server already, it's free because at this point the Linux software and environment for Ubuntu doesn't cost anything, whereas VMware is there's a cost to that. The reason that the right-hand side would be attractive is if you already have it. So if you already have a server with a virtual machine environment running, and you can use the cool kids term of you're just going to spin up another virtual machine, as long as you're running a Type 1 hypervisor, you can spin up a virtual machine for Telos Alliance containers and put Ubuntu on that virtual machine as your operating system. And as long as you've got the physical CPU cores available to allocate to that virtual machine. Again, remember, we're running real-time audio software, and it's not an Excel sheet that if it takes an extra second or two, it's not a big deal.
Right.
You really want this top performance. So as long as you've got the hardware reserves available on that server, no problem at all putting it on the VMware box.
I'll pop this up for a second. The situation on the left with Ubuntu Linux running directly on a server, let me see if this will pop right up. This is an old Dell server running Ubuntu Linux on a machine just a couple rooms down from where I'm sitting right now. And I'm running HTOP, which is a program that lets you see how busy things are. And this particular machine has 16 cores, 16 CPU cores. And I'm not sure I'm done with the configuration yet, but supposedly 6 of these cores are allocated to the 6 instances of audio consoles that are running on this machine. I have 6 IQS consoles. Cam will get more into that in a moment, but I just wanted you to see what this kind of looks like. There's no hypervisor here. It's just running Ubuntu on the bare metal, and then there are 6 Docker containers running on top of that.
Perfect. So We've talked a lot, and we have yet to talk about containers. So let's get to the meat of the matter here and talk about containerized software and what does that mean. So,
Hey, Cam, that is a heck of a tease, but I'm going to make it a tease, okay? You teaser,
make it a tease. We're going to get there finally after the break.
After the break, our show This Week in Radio Tech, episode 547, is with Kirk Harnack and Cam Eicher, and Cam is explaining about Docker and containerized software, and we're getting to that. We had to set this up so you could see where we are in terms of hypervisors, underlying operating systems, virtual machines, and we're going to get right into containerized software and how that works and why it's being deployed for lots of things. Our show This Week in Radio Tech is brought to you in part by our friends at Broadcast Bionics.
Camera One from Broadcast Bionics, designed to bring video to your audio content, visualizing radio and podcasts for social media. Camera One can automatically create, capture and brand professionally switched video for live streaming or upload, making your production shareable. Control and configure using a web browser on any device. Camera One is available as a 4-camera or 8-camera system using the Blackmagic A10 Mini range, including the A10 Mini Extreme. You can use cameras to suit your studio and your budget. You'll need one camera for a studio wide shot and usually one camera per microphone. A standard multi-channel sound card or IP driver monitors audio from each studio microphone, and we work natively with Axia systems. Ideally, this will be a post-fader feed from each mic, although you can use pre-fade audio or a mic split if that's all you have available. These audio levels are used to intelligently switch the video feed when each contributor is talking. You can also group microphones together into one shot and use the audio from a mixer's aux bus. You can use Camera One's auto switch feature or disable it and switch using the on-screen buttons or the buttons on the A10. Recordings can automatically start when you tell the system you're on the air. This on-air indication can be linked to your studio's red lights via IP or an Avantec Adam GPIO interface. You can quickly browse all the videos that have been automatically created during your broadcast, download them and post. Camera One is a user-installable system. You'll need a good spec Windows 10 PC, i7 with plenty of storage and 16 gig of RAM. It's better if this machine isn't used for anything else. Remember, you can control the software in a web browser on another device on your network. Camera One, a thrifty way of creating scroll-stopping video from your show or podcast from Broadcast Bionics.
You should check them out at bionic.radio, bionic.radio. Broadcast Bionics in the UK, they make some fantastic software to make terrific content for broadcasters, tested by some of the biggest broadcasters in England and Europe and in the U.S. as well. So check it out. All right, I'm Kirk Harnack along here with Cam Eicher. Cam has been really working hard on doing Docker deployments in his lab. Of course, our support guys, kind of make that easy for us. They do all the hard work, and then we just have to follow the directions and tell them where we fall apart following the directions. Maybe we would make the directions better. So, Cam, I guess we're ready to hit as you said, the meat of this matter, and that is Docker containers. What we really came here for.
Well, Docker containers. So as we look at this software, we've been bantering about virtual machines and everything else, and let's talk about Docker. And Docker is really a brand name, kind of like Kleenex at this point. So Docker is a set of utilities, originally, I believe, developed by Google, that helps it run containerized software. And so it's really an engine or a utility or a program, in a very simple speak, that has all the nuts and bolts inside of it that lets you run these containers of software. So it's possible that we did these slides maybe one out of order, and maybe we should have defined what a container is first, because we're now saying that Docker is a set of utilities that makes it easy to run containerized software. So what we're really talking about in the next slide here is what is a container. And what a container is an optimized virtual machine. So unlike a regular virtual machine, and by regular virtual machine, all the stuff we've talked about for the last 20 minutes or so, where you have to take a computer, create a virtual machine, and install a full operating system on that virtual machine, and then put your programs on top of that operating system, a container is highly optimized. So rather than giving you all the bits and pieces of an operating system, it gives you just the essential parts that are needed to run whatever your application is. So when you install the Telos Alliance container for IQS, one of the things you're not getting is Solitaire and Minesweeper. You keep those out. You don't really need it as part of the operating system. We don't need the other parts that have to do with printer drivers. You don't need the parts that have to do with languages. You don't need the parts that, again, there's so much that goes into an operating system that really is there for all the different things. If you think about what an operating system has to do, it has to be able to run any kind of software that you put on it. Well, the benefit of a container is that the software we're going to run is included in that container. And we know exactly what that software needs in terms of resources. We leave that in the container, and everything that software doesn't need comes right out of the container. And as a result, these deployments are quite small. They are quite streamlined. And that becomes really important when you talk about cloud deployments, because when you talk about cloud deployments, you're paying by the bit or by the byte or by the megabyte for your storage. So why would you want to store that 6 gigabyte Windows installer when you're not going to use 80% of it? Yeah. So the idea of optimizing your storage and making everything be as efficient as possible is really, really important inside the world of containerized software. So to look at these two slides kind of in tandem, Telos is providing you the software in a container, which is the software application and all of the bits and pieces needed to run it. And Docker, in this case, is the engine we've chosen to use to run this containerized software.
This is a standard. Containerized software has a standard to which people design their containerized software.
Exactly. And that's what we're just going to say. The standard here is called the OCI, Open Container Initiative, and Docker and our containers. So, our container is a Docker compliant container, or actually it's any Open Container Initiative can run it. And this is where the beauty of other types of uses can come in. So if you happen to be a house that's not running Ubuntu and you've got your own favorite version of Linux, you might be able to deploy this very successfully. If you're already running containerized software with a different container engine, as long as it's an OCI compliant engine, again, you should have the ability to run these containers without incident on the other platforms. From Telos' standpoint, we needed to pick a horse to ride, and one that we could support, one that we felt comfortable was well established and well updated and secure and had a long lifespan in the marketplace. So we've chosen Docker for that as our Docker engine. And we provide the tools in some of our automated scripting tools that will automatically download the Docker engine for you and stick it upon that Ubuntu operating system that you downloaded earlier and stuck on your machine. So we try to make that as transparent as possible for the people that are using our installer scripts.
Cool. All right. Oh, here's that big word.
At the beginning, Kirk mentioned my favorite word that got me into this. I got to go start figuring out what all these words need is Kubernetes. And what Kubernetes is a container management system. So kind of like the hypervisor manages your virtual machines, Kubernetes is a tool that helps you manage containers. So you might have hundreds and hundreds of containers running across lots of hosts, lots of physical machines. So this system will allow you to look at all of the containers you have, look for redundancy, spin up additional containers, scaling, automatic deployment of containers. So lots and lots of advanced features in terms of container software is managed by Kubernetes. Now, as we have just gotten started inside of Telos deploying containers, and most of our customers only have a couple of Telos Alliance containers that they're going to be running, Kubernetes is not something that's required or needed for any of our systems. This is back to, if you remember the VM slide that had the VMware ESXi. If a customer already has that, we're going to fold in really nicely into that system, and you can just spin up a hypervisor inside your VMware ESXi package and run Telos software on it. Just like Kubernetes, if you're already a shop that's container savvy and you're using software containers for some of your other virtual machine needs, then the Telos Alliance containers will fit right into that mix and allow you to manage our containers right alongside any of the other software you might already be using. So that's why we have the note up there that talks about large enterprise systems. And typically the customers have come to us with a, hey, I'm already a Kubernetes shop. Does your gear work? And the answer to that is yes. We're not mandating that people put this in, and certainly we're not prepared at this point to come in and train people on Kubernetes. So it's a kind of goes hand in hand with Docker. We hear the terminology not used interchangeably, but very often together, because people that are very into Docker already, there's a reasonable chance that they've got some experience or some exposure to Kubernetes. So it's worth putting the terminology out here so that when you hear it, you kind of know what it means and you know how it applies to the rest of the environment that we've been talking about.
All right.
And there's one final piece of the puzzle, that's how do you get this software? And the software we use, the software repository, we call it, is a company called Quay. It's actually been part of the Red Hat enterprise, which is another Linux deployment. But this is really an app store for containerized software. It can store all of these containers, which allows customers to go and get the software from this third party. It provides some features over just having it on a Telos FTP site. Certainly something like that used to work really well back in the 90s and the 2000s of, just go to this FTP site and download some software. What this does is it allows some version control. It allows you to type in things like you want to get the, quote, latest version of the software. So you don't have to know what the version number is. You just know that you're signing up for the latest package. And when updates are available, you'll be notified that there's an update available to your software. You could potentially sign up for the beta version, which allows you to get units that might not be as fully tested or, might have some experimental features in them, the whole idea of beta software, and you could be on the beta track. So we're able to publish software in a way that is more streamlined and allows both users and Telos to have a bit more control over how customers get the software and how they manage their downloads. So it does require that you set up a free account with Red Hat. Once that's done, then you enter your credentials for your Quay account that you've created, and Telos will authorize you access to our library of software. And from there, it's super easy, and you just get to download the software and stay up to date.
Okay. All right. I like the way you say that. It's like the App Store for container software.
It's the App Store for containers. Exactly.
Yeah.
That's what we've tried to do. We're trying to make this relatable. So what the whole picture looks like when you put it together, the left-hand side here is our bare metal running Linux. And inside that Linux, we're running the Docker engine. And the Docker engine happens to be running, in this case, our IQS mixing software. And that software was downloaded from the cloud repository called Quay. The right side, very much the same, with the addition of this layer of VMware. So here we have our bare metal running VMware. In that virtual machine, we're running Linux, and on that Linux machine, we're running the Docker engine, which is, again, running IQS. So same idea on both sides. And in fact, the user of IQS won't have any idea what's going on in the background. It's really about the infrastructure that you've put in place to run those. Now, what's great about wanting to learn this software is Telos can help set you up with a free demo of IQS. It requires you to go. We typically recommend the bare metal server because that's a little bit easier to manage than having to go a hypervisor route. So if you have a server that you can use for this and you're able to download and put Linux on it, we do have a version of IQS with an automated installer script that will allow you to, once you've registered, of course, for your Quay account, allow you to go and try this software out. And it does two things. At the end, you get a cool demo of a virtual mixer that you can play with, but it gives you a taste of what it takes to install and get some containerized software up and running. So you can get an idea of how difficult it is, how complicated it is. Are you running into any technical hurdles? Do you need to be more of a Linux guru than you thought? And it can answer some of those questions and help ease your mind about, do you have the chops available for this, or are you going to have to get some third-party help? Find a 16-year-old computer scientist that can help you navigate the world of container software. It seems to be my go-to thing whenever I need help, either with my iPhone or in this case, containers, right? You find your nephew, and then they'll take good care of you. So, in general, Kirk, that's that's kind of the landscape of definitions and how the new terminology plays into some of what we already know. Introducing these terms like Docker and Docker Engine and what's a Linux or an Ubuntu operating system and the difference between a regular hypervisor or a type 1 or a type 2 hypervisor, and just trying to help everybody understand that as we move into this world of containers, some of what you already know holds true, but there's a whole new set of terms and technology that could be really important. And that was the goal of this, is to get all of our team really comfortable with how all of the building blocks go together and how do you create these, new fangled containerized virtual machines.
Is that the extent of your presentation?
So now I figured you were going to have a question, because I can't have done that good a job where you don't have a question.
I will have questions. I'm going to pop my server back on screen here. This is a server, again, a couple rooms down the hall from my office, and this is an older Dell R710. It's got 16 cores and I think about 32 gigs of RAM, and just it does have rated hard drives, but it wasn't real expensive. I think this was about a $650, $700 off-lease server. And I fresh installed Ubuntu 20.04. I installed the desktop version. I could have installed the server version, but I installed the desktop version. And I'm a command line guy if somebody's holding my hand, right? And so I did what you're talking about here. I signed up for a Quay account for free. It's specific how you have to do that. There's a syntax that you need to follow. And then I requested from Telos. I said, I'd like to try the IQS console software and make my own console. Now, I'll give you a clue. I did already know something about IQS, this software audio console, because Telos Alliance, our employer, makes this available also pre-installed on a piece of hardware. So you can buy this piece of hardware called the Telos Alliance AE1000, Application Engine 1000, and you can have at the factory, they'll pre-install the IQS container on that for you. It's a little bit of a different install because it's running on an ARM processor, and so it's different than, I mean, you really don't want to do it in the field. We do it for you at the factory. And so I've had some chance to play with that. It's just simple. You plug it into your Axia network or AES67 network. It speaks both of those things, and you browse into the default IP address. You change the IP address to what you want, and then you've got a browser-based audio console. So I got that down and did some videos about that. Now I had the chance with Cam's encouragement to try out, okay, let me see if I can install this myself, this Docker. Now, Cam, my own experience maybe was a bit like yours. The first time I tried, maybe I didn't follow all the directions right, and I didn't get it right, and it failed. It would not install properly. And so I went back and I reread the directions. I realized, I see I went wrong here and here. So I'll save you all the birthing pains and just show you the baby. Once I figured it out, and it was just literally following the directions, but once I figured it out, I was able to install 6 audio consoles in 25 minutes. So, and if I could type faster, I probably would have done faster than that. And I did that using an installation script, I think you called it, that does all the hard work for you. You do answer a few questions. What's your Quay account? Tell me, are you going to install one IQS console or maybe multiple ones? And I had to answer a few questions on the script that was written by Telos engineers. And then everything else has happened automatically. And bam, I had 6 audio consoles in under half an hour.
The goal here is to try to make that process as easy as we can. There's some things we can't do. And as you said, I'm glad you mentioned that AE1000 option, because that is, as we mentioned at the beginning of the show, there are people that just want to buy boxes and appliances.
Yeah.
They want to plug something in, type in the IP address, and have it just work. And that's what the AE1000 option does. Is it's a off the shelf. You want to have the interface of a glass or a virtual console, and you don't really care what it's running on in the back rack room. So that's a great option. But if you like the density or you're into the virtual machine idea, then as you say, you can get 6, 8, 10, a dozen IQSs all running on a single RU server. So really powerful and really economical at the end of the day.
So I'm going to pop up an instance of Firefox here. And actually, this instance of Firefox, I'm actually running this over on that server that you saw. I could just as well run it on my desktop here. But this is browsed. This is actually browsed into that AE1000 engine. You see the IP address on my network is 10.216.0.29, and I just browsed into that one. I'm also running 6 instances on this Dell server. And so this is what you get. You can get, I think I've got this one licensed for maybe 24 faders. And be aware that I do have an Axia network here at my office. So this was sorry about that. This was fairly easy for me to get done. I'm trying to get this back on the screen for myself here. And there we go. I'm just trying to switch. You can see I got 12 faders on this one. I already have an Axia network, so I had plenty of things to bring up on the screen. And so I can bring these faders up and down. I could run more browsers on different computers inside my network, or if I could give it access from the outside of my network here, and I could do all these same things, run these volumes up and down. You can see it's mixing. It's providing a program 1 output. This won't all fit on the screen. Sorry about that. I guess if I would reduce the size of the screen, I might be able to fit it on there better. But anyway, let me see if I can bring that back down to 100%. There you can see all the faders better. And I can turn faders on and off like that. So if you haven't seen the demo of the IQS, there's videos on the Telos Alliance YouTube channel showing you that. But this is what you end up with. Cam, I also tried installing this. Let me minimize this just for grins. I tried installing this on a much more modest machine. I have an old Dell Optiplex. I think it's a 755 or 955 or so. I don't know. It's a Core 2 Duo machine. And I installed Ubuntu Linux on that, and I installed one instance of this Docker container software on it, and it works beautifully. I don't know if that's what we recommend, but for me, it's working just great.
Well, I would tell you that if you have a computer that old, you might take it to the museum. But if you really wanted to use it, I will admit that the first time I needed to try this was a cold day in February. And the only computer that I had that I was willing to reformat for this exercise was a similar Core 2 machine. And it takes up about 50-60% of the CPU power to do it. It'll churn away and work, and that just shows the how light these containers are. Now, some are more. If you're going to try to run an Omnia 9, it's never going to work on an old Core 2 like that. Right. But IQS is a pretty lightweight container, and it can work. We always go a conservative route, and I owe that to my beginning of my broadcast career working with satellite dishes, and part of my job was to talk broadcasters out of using their 10-foot mesh dish, and how of course it works until it doesn't. So
exactly.
If that's where all your revenue is coming from, you probably want a 3-meter, 3.8 meter dish, and you know how that goes. So I think the idea is, best practices. If you want to have a play with this, then certainly most machines made in the last 6, 8, 10 years should allow you to run a container without too much difficulty. But if you really want the right experience and you want to even take it for a spin, in kind of the environment you might have on air, or should you choose to buy something, as Kirk said, you can get a really, really nice computer for just a few $100s, and that's really the route to go. Is we don't really want to endorse, blowing the dust off something and thinking it's going to be a great air machine.
So running an audio package, an audio application is a bit CPU intensive because we have a lot of real time or very close to real time the things that we're doing. We don't have many microseconds between the time that we need the next addition or subtraction or operation to occur, which brings up a point here. We've demonstrated here this audio console, this IQS software audio console running in not just a virtual machine, but running in a containerized environment. There are other broadcast broadcast functionalities that are coming to market. And one of them is a phone system. A lot of folks are familiar with the SIP phone system, multi-line, multi-studio system that Telos makes called the VX. It's available in kind of a baby brother and a full-size unit. But now that's available in a Docker container. And it's just like the hardware box that Telos sells.
Exactly. So just released within the last 30 days or so is the VXS, like IQS, indicating the software version of this. And it's a 100% virtual system. Now, the cool thing is that when you pull the cover off of a VX Enterprise, which is the hardware appliance equivalent, everybody knows that's an industrial server that's running VX Enterprise. It's running a real-time operating system, and life is really good. So if you want to emulate that performance, it can't be running Windows, it can't be running something else, and now we're back into this highly optimized Docker container that lets you run something like a phone system. The great news is that it's really scalable, so you could run it down to a 1 or 2 channel or a 1 or 2 hybrid telephone system, or up to 100 or more hybrids inside of a single box. So it's all about how you want to deploy this, and do you want to buy Telos's appliance, or do you want to buy the software from Telos and deploy it either on your own hardware or on some sort of cloud-hosted system. And it's fantastic. Recently released is the Infinity VIP virtual intercom platform, which is another Docker container. And if you were a fortune teller and you were starting to bet on what other products might be coming from Telos in the virtual world, you would probably be right. So there's a lot of development happening. It's a great way to manage and distribute software. And as Kirk said, it's not something that just fell off the turnip truck yesterday in terms of a platform. Docker is almost 10 years old in containerized software. It's what things like Netflix runs on. This is really bulletproof, tried and true platforms that we've chosen. And that's part of the reason we've chosen them, is that other high demand, high intensity broadcasting type platforms are using these same kind of deployments because of the scalability and the redundancy and the density that they can get from this containerized software.
Yeah, a few TWiRT shows ago, I had our friend Jake Alderman on the show with me, and he was a little deeper in the weeds as to Docker containers. And he pointed out that, look, this is actually big-time stuff. You mentioned Netflix. He mentioned PayPal is using lots of Docker containers. They're little engines that do things. They don't have to be little. They can be a 24-channel audio console with lots of mic processing, for example, and EQ and all that, and backfeeds and mix minuses and all that. And I said, really? PayPal's using it? And I got my phone out, and I happened to know. I sent him $1 during the show. I said, I just used a Docker. I sent you $1. And you know what that Jake Alderman did? He sent it back. He wouldn't even keep my $1.
Well, I'll tell you, every time I go to Cleveland, Jake wants me to buy dinner for him. So I'm going to remember that the next time and say, you
can buy me
owe
dinner.
me dinner. That's exactly right. No,
God.
Jake is a great resource. He's one of the great minds inside Telos that, he would listen to this presentation and either he would have been asleep by the third sentence I talked, or he's pulling his hair out going, well, that's not exactly how this works. He's a brilliant mind, as are many of the folks inside of Telos that are not only developing how this software works, but how it installs and trying to make it easy for radio broadcasters to deploy it. My role here is like you. I sat down with Jake one day, and after about an hour, my head was spinning, and I said, I've got to figure out a way where I can understand this because, he's at the 300 level classes, and I'm still in kindergarten here on some of this stuff. So that's some of the goal here is to really break this down, and the audience of TWiRT is such a wide-ranging group of people, as you said, folks that maybe are hearing about Docker for the first time, and others that are busy typing up a letter to the editor right now with all the corrections that they need to make on my commentary,
right.
which, by the way, I will be happy to hear because anything we can do to make this better is appreciated. But it's we think it's a great intro, and it kind of helps frame up some of the building blocks and the terminology on which all this container stuff is going to go on.
Hey, Cam, we're going to have a tip of the week coming up right after this next commercial break. So we'll be back with just a closing word or two on This Week in Radio Tech. Our show, This Week in Radio Tech, is brought to you in part by my friends over at Max Connect Wireless. And here's a good word from John Takak about why Max Connect Wireless is perfect for broadcast engineers and facilities.
With all of the recent cybersecurity attacks against large corporations, we were looking for a product that would give us the ultimate security at our transmitter sites and as well as with our broadcast equipment. Max Connect fits the bill very well. Its greatest security feature is the fact that it gives you a single static IP address. Using this single static IP address allows us to close hundreds of open ports on our firewalls across the company and restrict access to only the Max Connect IPs. This has greatly reduced our exposure to the World Wide Web and made us much more secure moving forward. It's also given us the ability to expand as needed in a secure fashion.
Thanks, John. And Max Connect Wireless uses little modems like this one. There's different modems available, but it's not the modem that's the secret. It's the SIM card, because it's a Max Connect Wireless SIM card inside. Now, you can get these for the major carriers, for AT&T, Verizon, T-Mobile, and Sprint, and even becoming available in Canada now. So Josh Bone, broadcast engineer and station owner, has really put together a great service here because you get prioritized data. You can be in a coliseum full of people, and we're starting to see people come back to sports games now that COVID is just about getting over, and you get good connections. You get all your packets to get through and a fixed IP address, as John mentioned. Check out Max Connect Wireless. It's spelled funny. Look in the show notes, maxconnectwireless.com. Hey, our show is also brought to you by Angry Audio, and they make my favorite no snag your pantyhose my headphone amplifier. This has got the Studio Hub standard on the back for audio in and for looping audio back out, and also for powering this headphone. This is called the Headphone Gizmo. You can power it right here with an external wall wart, and you can also use this to inject power for another amplifier and another amplifier down the line. So you can put these in your studio. You just screw them right up under the console, and they already have little rubber feet on them, so they're quiet. They don't sit there and wobble. And if you don't want to screw it into the console, you can just lay it on top of the console like this, and it won't move around because of those rubber feet. It's got both kinds of headphone jacks, country and western, right? 1/4 inch and 1/8 inch, and a great volume. So check that out. The Headphone Gizmo from Angry Audio at angryaudio.com. And Angry Audio bought the whole Studio Hub. Whole kit and caboodle. So you can get all your favorite Studio Hub adapters, like the ones with the male XLR already there, or the ones with the female XLR that you plug a Cat5 cable into, run it wherever you need to, and plug it right into the back of your Axia X node or your old radio systems console, or anything that's got the Studio Hub standard for its audio input and output. And matters not whether it's AES EBU or whether it's analog, it still works either way. In fact, right here's one that's built for AES EBU because it's just one cable right there. And they even have the long cables too. If you don't want to use the Cat5 cable like I do with this kind of adapter, you can get these in all different lengths right, I think this one's a 6 foot length with the RJ45 and the XLRs on, and you can get other things besides XLRs as well. And the latest thing are these little adapters. These would typically be used for AES EBU, but you could use mono balanced audio. It's just here's a female XLR to RJ45, and here's a male XLR to RJ45. And if you just want to connect two RJ45s together with 3 conductors, you can use. This won't make a network cable. Don't do that. Check it out at angryaudio.com. Remember, don't get mad. Get angry with angryaudio.com. Thanks for sponsoring, too, This Week in Radio Tech. All right, Cam Eicher, we just got to wrap this thing up, and maybe you have a final thought, but my final thought on this is, look, you don't have to do Docker. Companies like our employer, Telos Alliance, is making available broadcast equipment as both hardware, that's what you want, no problem. I've got a hardware IQS console right across the room here, or as a Docker container that you can install yourself in your own IT area. And, hey, if the computer dies, you just move the license to a new computer. I think it's going to be the future, not for everybody right away, but there are broadcasters who are very interested in doing this.
Well, Kirk, in the 200 years that you and I have been broadcasters, we've witnessed, transitions from analog to digital, from turntables to CDs, from cart machines to automation systems, from, AM to digital AM. We've just witnessed the industry constantly evolving and constantly changing. And this is just another chapter in the book. So we encourage all of your listeners and everybody here at the TWiRT family, wherever you are in the journey to virtualization, it's a great opportunity to learn. It's a great opportunity to give this a try. And as your station could benefit from virtualized software or any type of density, talk to the folks at Telos, and they'll help guide you towards the right solution for your application, whether it's buying a piece of hardware or picking up a piece of software, doing it on your own, or hiring some help. We're all in this together. We're all going through this journey. And that's really the goal here, is that to know you've got friends and resources and colleagues inside of Telos that want to help you be a better broadcaster.
Cam, very, very well said. Thank you. And I really think I've kind of been preaching about this on white papers and NAB, and it wasn't necessarily my idea. Steve Church years ago was talking about the world moving this way, and it certainly has. So, hey, and my word to broadcast engineers is learn about this stuff, because you're probably going to need to. You can't live in the box era forever. Maybe a few more years, but you're going to need to know about this technology, and we're here to help. And the good news is you don't have to learn about Docker containers only from Telos Alliance. There's many hours of instruction about containerized software on YouTube, for example, and there's college courses on it and books about it. So there's lots of places to learn about it.
Well, and there's only 5 bearings left for a triple-deck cart machine in the entire world, so we're going to have to move into this direction sooner or later.
That's right. All right, my guest has been Cam Eicher. Cam, thank you for joining us. I sure appreciate seeing you, and we'll see you on a future show sometime, okay?
Well, thanks to you, Kirk, and TWiRT, we appreciate the opportunity. Good to see you guys.
Thank you. This Week in Radio Tech. Hey, I really appreciate all of our sponsors. So if you would patronize them, let them know that you heard about them on This Week in Radio Tech. Thanks a lot to Suncast, who's been busy putting the lower thirds on the screen and taking care of lots of other technicalities. Thank you, Suncast. And thanks also to Andrew Zarian, the founder of the GFQ Network. And you'll find other fine podcasts on the GFQ Network. So check them out. We're going to see you next week on This Week in Radio Tech. Bye-bye.